Okay, last time we talked about the logic gates, and we discussed, I think, a couple of them, and, or, and NAND, and NOR. And we had also established the truth table for each one of them. But today we will go over the time or timing analysis. We're trying to have an input signal at one of these gates, and we will see how will be the output at the X or Y for either AND, or NAND, or NOR. So let's just take basically a very simple example, and then we'll have more complicated, to a certain extent, examples. Let's say we have this AND, and we have these two inputs, A and B, and we have the output X. Let's say we have this clock signal. Okay, this is the clock. That means this is what we have at A. So we need another clock basically, or another signal, somehow like word generator, at terminal B. And let's say, just to have the same example we have here, no. So we have this signal, and we have it 0. So this is basically A, and this is B, right? So if we try to, again, this is the same level. So if we're trying to trace the output of this, or of these two signals, we should expect something like this. This is AND, right? So to have a high output, we should have both input high, right? So again, since this is 0, 0, it will be 0, and this is high, and this is high. Hold on, let me just try. Okay, so basically we have high and 0, then it's 0. So we should expect something to come out here, right? So we should expect something to come out here, and then 0. And since we have one of the terminals 0, so we should expect the waveform to be 0 all the way to the end cycle, or to the end of this interval. So this is basically at X. As you see, it's very simple. But right now, if we have, let's say, another gate, let's say we have OR. So let's say we have OR. So we have A, and we have B, and we have, let's say, X. And let's say we have this wave form at terminal A. Let's say we have this. And we have at terminal B this signal. Okay, so this is terminal B. As you know, if one of the terminal is just high, we should expect high output at terminal X. And again, this is very simple, but I'm trying after this example to throw like a tricky example and to work like backward. We have the output and we're trying to figure out the input. But before we go to that example, we need to just set up some simple example like this one. Again, since this is both of them 0, we should expect 0 up to this point. And since one of the terminal, so we should go up all the way here, right? And then we have here also 1 up to here, right? Then we go 0, then we go 0, then we go up again. So it's very simple, right? Let's say we have this example now, the AND gate, right? And we have, again, we just taking it like 2 inputs. We can have it 3 inputs, 4 inputs, but we're trying to make it as simple as possible to understand the principles first. So we have A, we have B, and we have X, right? Let's say the input or the waveform for input A is given, and is given in this fashion. We have this, we have that, okay? Just very like 1, 2, 3, let's say period or cycle. This is A. But guess what? Now we're given the output, and the output looks like this. So I want to be careful. So the output looks like this. Okay? So then it's going down like this. Again to the mid of this, and again is going down. So this is X. He's asking to find B. So it's not kind of like straightforward, but we have to think about it. But it's very simple because, you know, this is just like a linear, right, equation or relationship. Since we have an AND gate to have high output, we should have both inputs to be high, right? So since we have both of them 0, so basically we don't care, okay? We don't care whether it's 0 or 1. So let's just have the form first like this, okay? And let's just have some draw here. We don't care. This means it could be 0 or 1. Okay, this is basically how we represent that. However, here we have high. I cannot say we don't care. It gotta be high, so it gotta be 1, right? Yeah, because here we have
X is low when A is high, so B should be low.
here.
Yeah.
Small space between them.
Yeah, there is a little.
Where? Hold on.
X is low when A is high, so B must be low.
If this is
No, the second
here,
before it.
هون
Yeah. X is low.
well مثل ما حكت هي في الرسم مش دقيق طبعا احنا we say up to here,
Yeah.
right? So let's try to perfect it. That's fine. Okay. Up to here we don't care basically. Since we have high here and we have one of the terminal high, definitely this terminal should be high. and this is up to here, let's say, okay? Now, since we have the output is 0, again, we don't care. Or, yes, we don't care. Up to here, so up to here. Should be up to here, right? I know it's confusing. So what we should expect here also. Here we should expect, hold on, this is, we don't care, right? We don't care. But here we should expect high voltage, right? And since the output is 0, we don't care. So it's very simple again. So why we're asking these kind of questions? Sometimes we trying to accomplish certain task out of this digital circuit. So we could ask ourselves what we have to have, what we need to use as a logic gate to give me this certain output. So we could also have OR gate, right? Yeah. So let's say if we have this OR gate, A and B, of course things will be different, right? So let's say we have this waveform. This is A, and B is given this in this format. Let's say up to here, okay? Or no, it's up to the end, and then it's going down, and goes up again, and goes like this. This is X for this. So here definitely it should be 0, right? So we should expect terminal B to be 0. But we don't care whether it's 1 or 0 because this is OR, right? If this input is 1, so the B could be 1 or 0, right? So it's simple. So let's go all the way up to here, right? And let's analyze it again. So we have 0 here. So B now should be 1. So up to here, let's say I don't care, but absolutely here it's gonna be 1. Everyone follow me? Okay. Now let's continue. So now this is terminal A is 1, and we have 0, so I don't care, right? So it's gonna be...
No, it must be 0.
No, I'm sorry, the output is 0. I'm sorry, the output is 0. So basically, sorry?
It can be.
Hold on. So, hold on, let's analyze it. It could be wrong because probably I'm not following exactly the example here. So we have the terminal 1, and we have the output is 0. So this is absolutely, it can't be. Right? So if that is happening in the exam, how we gotta do it? What we gotta solve? How you will elaborate in this problem? كيف راح تعالجوا هذه المشكلة؟ توقف أو تحكي إنه السؤال خطأ. أوكي؟ طبعا هذا مختلف عن اللي أنا معطيكم إياه هون. فصحيح. لكن طبعا هذا صحيح إذا بيكون عندنا إيش مثلا AND gate. أوكي؟ فإذا الفكرة إنه إحنا we should look at the wave and analyze it. Deal with it as it is. If it makes sense, it does. If it's not, we basically reject it, or we start to elaborate more and think about it. What's wrong with the signal? You are right. We have OR and we have 1. So basically it can't be low. So let's just basically correct it. So if we corrected, we have 1. So at this point, what we should expect?
Don't care.
Don't care. And since we have also 1 here, or 0 at the input, it should be 1, right? And I think it's straightforward to a certain extent, but يعني we need to practice it يعني نحل أكثر وأكثر من الأسئلة. لكن حقيقة هي الأمور بتتعقد أكثر وأكثر once we have more logic gates, right? We have, let's say, 4 or 5 of them. Once we have 4 or 5 of them, and let's say we have inverter, we have Noor, we have XOR, هلا بيجي قضية الادvantage to use the simulation. It's very easy to make a mistake here, even if you practice it 100 times, right? On the top of that, it will take a lot of time to analyze it. لكن مثل ما أنا راح أورجيكم الآن، حتى لو يكون عندي كذا logic gate, okay, regardless how much they are complicated, we can just within 1 click inject signal at each terminal, 1, 2, 5 terminals, 100 terminals, and get the output like this, right? Isn't it cool? It is. So that's why I encourage everyone to use, or at least to have some hands-on experience on this simulation. هلا خلينا نتطرق لشيء ثاني اللي هو enable disable function. Enable disable function. Let's say I have a signal. I want to transmit it for like 4 cycle, 4 period. Then I want to suppress it. بدي أوقفها. Make it 0. فإذا صرت أنا أشتغل بالcontrol، صح؟ فأنا want to enable the signal for certain period. Then receiver راح يستقبل الإشارة. Then disable transferring signal. Then enable it again. حقيقة we can do it with multiple things, right? But using these gates, very simple gates, we can deliver this task. We can deliver this mission effectively. So let's take a look at this example. Let's say we have a clock. We have a clock. Oscillator, for example. And we have this AND. Okay? So the clock is connected to this input, 1 terminal. And we have another terminal, we call it enable. Enable signal. Okay? And we have a receiver here. We have a receiver. This is just dot. So let's try, let's say we have 1 megahertz input, or this clock, it generates a signal at 1 megahertz. So we have this, let's say, waveform. Let's have like 6 of them. So this is the clock. So this is 1, 2 cycle, 3 cycle, 4 cycle. Okay? He's asking if we were basically enable this signal the first 4 cycle, then suppress it, stop it. How I would basically deliver that, how I would do that. So the enable signal, exactly, since we have AND to replicate, يعني نساوي يعني replication، يعني ايش اللي هو energy، اوكي، للسيجنال على الاوتبوت هون، لابد انه يكون هذا هاي، right؟ فاذا عندي انا هاي راح يكون الزيرو 0 وال1 1، صح؟ فبasically I'm replicating, I'm regenerating the same input signal. فبasically enable line if you will call it this line, should be, let's say, high from here. Sorry. It should be high from here all the way up to here, let's say, right? And then I should shut it down, 0. So from here, it goes 0. So if I wanna, this is enable now. Now, what is X? Again, similar to what we just have done, right? So X would be the same, right? We're not doing anything. 0 is 0, 1 is 1. So we'll have 0. No, this is not good color. So let's have black. Then it's 0 basically, right? Then it's 0. Because regardless what you put at these terminals, since the enable is 0, it just basically the output will be very much 0. You see how basically it's so simple to use one gate, one logic gate, to deliver certain task, like, okay, allowing the signal to be transmitted within this period or within this region, and then suppress it. This is good for telecommunication then, right? Or other applications. I don't want you to hold, I don't want anyone to hold me, for this, just, oh, this is for only telecommunication. No, for a lot of applications, just for the, I'm just mentioning here examples, right? Yes. هو السؤال مثلا انت بروجرامر تشتغلي على ابلكيشن معين، انا بحكي انه هذا الروبوت بده يتحرك مثلا خلال مثلا كذا بيريود او كذا سكند، لانه انا بعرف انه الكنترولر generate continuous wave signal like this every certain period. فانا بقدر احسب اوكي الروبوت انا بدي مثلا suppress the output signal within let's say 2 microsecond. فانا بعرف انه how many period. يعني هذا بيجي للابلكيشن والبروجرامر، ممكن يكون مثلا one cycle. اوكي. لا هو بيفرق من سؤال لسؤال طبعا.
يعني لو كان 2 أو 3 راح يختلف الحاسب.
طبعا راح هو نفس البيريود بس the time the interval راح تختلف. مثلا عندي ال 1 ميج راح تكون ايش البيريود اللي هي 1 micro, right? If let's say we have 2 meg, we have half microsecond, and so on and so forth. But as far as the number of cycle, if I said, okay, let's say I need to deliver this signal for 4 in a period or 5 periods. هذا السؤال طبعا اختلف، فبدنا نيجي ناخذ لهون ال 5 period, right? أو مثلا 2 period بس لهون. أو مثلا ممكن أقول okay, I needed to deliver 2 period, suppress it for another 2 period, enable it again for let's say the 6th one. يعني بس المبدأ واضح. طيب هلا how about if we have OR, right? If we have OR gate here, I think we can just copy it. Okay, we'll do it again. So let's have a clock. And we have this OR. This is the enable. This is the clock. This is the output. Let's call it Y. And we have a receiver here, let's say. Receiver. Again, let's say we have this clock trace. Okay, this is the clock. And let's say we have 1, 2, 3, 4, 5, 6 period. Just for the sake of example. At 2, we enable it from 1 to 2. This is the enable. Then it went down all the way to 5. Right? And then we enable it again. I'm sorry?
When it is high, it's
Yeah, just for a moment. You're right. We just disable it. ليش?
When it's high, the output is high regardless what they
So
say.
basically we suppress the input signal for this one, right? So إذا بنتذكر لا راح يكون العكس تماما من هذا. Okay? هلا we disable it basically at high input voltage, right? خلينا نشوف ليش بالضبط. هلا if one we have at enable it's gonna be 1, right? We don't need that. We need the actual signal.
Yeah.
Right? So basically what you will have this. We have high
Yeah.
and then it's high, then it's 0,
high,
then high,
0,
0,
high,
high,
0.
then again. Then what we should expect? All the way high, right? So this, we call this disable, right? Region.
Before that,
I'm sorry?
there's
That's from here.
Oh, sorry, from this point.
yeah.
From this point, we basically
Able the signal.
disable it. No, all the way here,
No,
up to here.
This is it's the input signal.
It's gonna be all the way high up to here, right?
But this is the signal.
But the signal here.
This
Oh,
is
from the
last-
same thing, it's high, right? So then up to here. Disable. And from here, all the way to here,
enabled.
enable. And again disabled. طيب هلا معناته احنا we can use it as a combination, right? Use both and or and
And
or gate,
Yeah.
okay? To again do certain function, logic basically, task or yes.
لما تكون enable زيرو مش المفروض انه ما يكون شغال الكنترول اللي بتعمل فيه معناها لازم يكون دائما زيرو.
It depends. هلا هو هون disabled from perspective of this logic gate. but بالنسبة للcontrol, yes you are sending high voltage.
we can put an
Right.
inverter.
فأنت basically وكأنه طبعا إذا بدنا ندخل inverter شغلة ثانية نفس المبدأ طبعا.
Yeah.
أنت حقيقة yes you're sending high voltage
To disable the
from a controller perspective you are enabling, but from an application perspective for this circuit you are disabling the signal. يعني هي حقيقة it depends كيف أنت بتنظر للموضوع، مش كيف بننظر للموضوع، وين إحنا بننظر إنه disable و enable. From a controller perspective, yes, it's enable. From this digital logic circuitry, it's disabled region around this period. I mean around this region. طبعا الانفرتر الكل اكيد بيعرف الانفرتر. طب شو فائدة الانفرتر؟ Why we use the inverter? Signal. طب why we use so the inverter just very much it's how many terminals we have for the inverter? One, and we have output 1, right? So if this is an inverter,
No.
ايش هذا؟ buffer. So what we use the buffer for? To hold the data for a certain time. So basically we have delay, right? we need to have some delay in certain, let's say, stage during the transition of the data, so we can use buffer, right? So it holds the data. But this is a buffer, and this is what I'm looking for, inverter, right? So basically very much 1 0 0 1. And هذا معروف كمان بالنسبة لكم. يعني أنا متأكد كل اللي أخذوا الديجيتال لوجيك من قبل طبعا هذه أمور بديهية، بس يعني من باب إن نذكر بعضنا. يس.
المثال السابق ممكن تعيده؟ disable وال enable.
اه
فهم انت مش فاهم؟
مش فاهم. طيب خلينا نرجع شوي. ال enable و disable is nothing more than a signal. هي مش أكثر ما إنه signal. يا منحط 1 يا منحط 0 على هذا ال enable، صح؟ يا إما تكون ممكن 0 أو ممكن تكون 1. right؟ فبعدها نيجي من أوكي إذا كان عندي 1 مثلا هون على هذا التيرمينال 1، شو بده يكون الاوتبوت اذا في عندي هذا الكلوك ويف وعندي انا اور؟ اذا عندي واحد من التيرمينال 1 هاي، اذا الاوتبوت راح يكون هاي، صح؟ هلا اذا بتكون اند وعندي 1، مش شرط انها تكون الاوتبوت 1، ممكن يكون 0 ممكن 1، لانه لازم يكون both input terminals high to have an output high, right? So enable مش اكثر ما انه هي عباره عن سيجنال. السيجنال هذه اما تكون 0 او 1. فانا مثلا باجي بسال اوكي انا مثلا ببرمج شيء معين لابلكيشن معين، بحكي اوكي انا بدي اول 2 سايكل مثلا او اول 4 سايكل whatever، اوكي بدي يعني transmitted as it is، بدي ارسلهم مثل ما هي السيجنال، بديش اغير فيهم. فمثلا اذا بدي استخدم اور، اذا بستخدم 1 حقيقة راح تطلع الاوتبوت اذا كانت السيجنال 0 راح يطلع 1. فانا من هنا ايش؟ suppress it, I disable this signal, I change it basically, right? لكن حتى اني يعني اخذ output an image for this input signal، بقدر احط على this terminal 0 basically, right? فبالتالي اذا 0 راح تطلع 0 واذا 1 راح يطلع 1. طبعا التحليل هذا مختلف اذا بيكون عندنا الجيت، اذا بيكون عندنا الجيت اند مختلف. ف هلا انا بدي نشتغل على المالتي سيم. I will connect my computer to the projector وراح نرسم سيركت شبيهة بهذول السيركتس ونورجي كيف يعني live simulation. So this is basically multi-sim, right? This is multi-sim. I already drew the circuit. Let's say this one. So what we have word generator. It just basically generates signals from 0 to 32 bit. So we can use multiple input as we showed here. Rather than 1 clock, we have several of them, but in different period. هذا الword generator. هي إذا بنطلع على اليمين هنا شايفين في عنا عدة function generator, multimeter. شايفين هنا مبين؟ فهنا كمان في عنا function generator، في عنا watt meter. يعني حقيقة انتو kind of like you are working in the lab virtually، افتراضي. كل الاكويبمنت اللي عندنا في المختبرات عندنا اياها في السوفت وير هون literally. فيعني this is you can use it from now on. It's very accurate. This is I mean at the industry standard. Okay, they use it in the industry. Very reliable from National Instruments. الشركة اللي يعني اللي مصنع هذا السوفت وير National Instruments is very well known company all over the world. Okay. مثلا في عندنا ايش كمان؟ في عندنا الاوسيلوسكوب. في عندنا 4 channel اوسيلوسكوب اللي احنا استخدمناه. اذا بتشوفوا هنا 4 channel اوسيلوسكوب، صح؟ ليش؟ لاني انا I need to probe at what? I need to probe at 2 input and I need to probe also at 4th output. I mean 2 output. So I need basically 4 channels. What else we have? We have word generator. That's what I'm using right now. Word generator, you see here, this one? That's what I'm using, this chip, kind of, to generate the signal for me. Because look here, you see this? I'm taking the output of this word generator from this pin and this pin, and I have it as an input for and I have it for or. طبعا هون الcolor, if you click on it, you can change any color you want. So basically you will figure out once you open the oscilloscope home into a signal you should expecting. Okay. فيعني it's very useful and it's very يعني easy to use. فطبعا خلينا نسكر هلا عبين ما go over it. So I have this circuit, okay, and I have certain input. هسه we will see يعني شو الانبوت اللي على كل gate, and we're trying to figure out the output, right? So once we just set up or draw the circuit here, and we have the oscilloscope, I can run the simulation here. See the green line? I mean the bottom. So we run the simulation, and now here is my signal. Is it moving? Yeah, it's moving, right? So it's moving. Let's stop it to try to analyze it now. Stop. So again, let me just work on my side first. Okay. So what I have the blue as what? I have the blue as an input, right? So this is the first signal. And I have the red as the second input. I have the yellow, this one, right? The output for the AND. And I have the green is for the output for the OR, right? So basically, I'm good right now. I know this is 2 inputs, and this is like the outputs. Look at it by yourself and see if the really simulator does the job perfectly and right. It does, right? So this is one of the advantages, as I mentioned, to start, practice or familiar yourself with the simulation, with these softwares. We can basically go here, place, you see the components, and we have a huge library you can choose from. Now when it comes to the TTL, which is next week, this is very tricky, to analyze it. We gotta use this simulation also to help us understand the circuit. At what level this transistor logic circuit is on and off. Okay, so we can use this simulation to help us trace and track the progress of the signal at the input level and at the output level. So as you see, if you need very much simple circuit, voltage, resistor, connected in series, in parallel, you can do it here as well. So let's say we choose this AND. All I need to do is just okay, and you bring it here, right? Did it take it? I think, we have to choose, let's say C, and here cancel, and again cancel that. So here is basically your component. You need to take it anywhere, just highlight it and drag it. You know how to drag it with the mouse. You just hold the mouse and drag it somewhere else. So if you need, where is that? Okay, so let's say you need to rotate it, Control R, okay? Control R, you need to rotate it. You need to place a wire, very much, look. You click outside the symbol. You see how that black dot, it got enabled. You take it and you connect it somewhere else. It has a smart, a connection system. So you don't have to worry if it's like short or not short. It does the calculation, the connection by itself. You don't have to worry about it. All you need to do is just basically hold the wire and take it wherever you want to go, right? So it does the job for you. What else? So again, basically, all you need to know, you need to get out of the wires, escape. Okay, escape. All you need to do here is basically the components. Okay, sometimes you have popular components listed in the top menu here in the tools in toolbar. You can choose it from there, right? The best thing is to have it at your laptop if you want to really learn it and study it and adapt it. يعني تستخدموه يعني وتعتبروه يعني فعلا هو السوفت وير اللي ممكن يساعدكم في البروجكت في الاندستري from now on. حطوه على اللابتوب تاعكم او البي سي وات هوم at your يعني at your convenience explore يعني go over every single icon. بعدين في عندنا كثير بي دي اف تشرح عن هذا السوفت وير، وفي عندنا كمان يوتيوب name it. فانا بشجع كل واحد انه يتعلمه. طبعا انا حطيت هنا سيركت بسيطه بس عشان نوصل الفكره. مثلا على سبيل المثال اظن في كمان سيركت ثانيه للأسف اللي يبدو ما مش مسيفها ومسكر كان الكمبيوتر. هلا بتذكروا last time also ورجيت بعض الطلاب simulation للريلي، اوكي، لأن الريلي سوى لنا مشكلة. ف this is the relay right. طبعا أنا مش عارف أي واحد منهم هسه، بس أما طبعا run السيميوليشن يعني شايفين هنا هذا الريلي، كل هذا ريلي very much basically just you know simple circuit and I'm trying to figure out what is the output right. خلينا نفحص مثلا شو هو هذا النوع من الريلي. أنا ما بعرف شو هذا النوع من الريلي على سبيل المثال. ف I run the simulation okay I come back to the oscilloscope. خلينا نأخذ wave مليح I stop it. هلا طبعا هني signals on the top of each other right. شوفوا كيف في functionality هنا واضح. موجود عندكم. خلينا نكبر الويندو. هلا قبل ذلك احنا شو الانبوت سيجنال اللون تاعها blue right. That is my input and that is basically my output right. So the output is the yellow so it doesn't make يعني احيانا افضل ان ننزلها نبعد مثلا الويفز عن بعضهم. فهون شايف هون نيجي click I can basically adjust the position of the wave right. I can also adjust the scale the x-axis for the wave as well. So you can do a lot of things over this oscilloscope interference window. فهو حقيقة كأنه بنشتغل في اللاب صح؟ فهذا النوع طبعا من الابليكيشن طب شو هذا هو ان او ولا ان سي؟ هذا بيكون عندنا زيرو وبيكون عندنا هاي، فهو عبارة عن ان او اوكي. هلا اتذكروا كيف انه زيرو high zero. This is an O or an C. Hold on. An O means V applied across the rod. The rod is zero. So if it's zero, it's open. So what you have high voltage. So this is an O. This is an O. ال NC اللي هو normally contacted. فلما يكون V0 الاوتبوت ايش بده يكون؟ short zero. اللي هو طبعا هذا. خلينا نجرب فعلا نشوف انه صح ولا مش صح. Control X I put it here and I bring the other one down. So then I start connect. You see, I connect this. This is with the input. I ground these two terminals. Let's run it. Let's look at the output. You see? So this is how basically I verify بأكد إنه فعلا فهمي صح، السيميوليشن صح، السيركت behaves يعني behaves as it's supposed to ولا لا. طبعا مرة ثانية هذولا very simple just two elements. ممكن يكون عندنا millions of elements في سيركت واحدة. طبعا مش بهالشكل طبعا راح يكون، لكن ما أقصد إنه ممكن يكون عندي أكثر من elements. بطريقة يدوية صعب إن احنا نحلل هذا السيركت، فبنستخدم مثل هيك سوفت وير. طبعا مش هذا السوفت وير الوحيد الموجود، في طبعا بي سبايس أنا طبعا بشجع كل الطلاب إنهم يتعلموه. أي سؤال؟
ايش السوفت وير هون؟
ايش اسمه؟ مالتي سيم. مالتي سيم اظن موجود كمان في السيلبس. شغله ثاني مثلا، خلينا بما انه في معنا لسه وقت، مثلا انا بدي اعرف بالضبط، عندي سيركت كبير عده اليمنتس، بدي اعرف بنقطه معينه شو الفولتج. فاطلع هون شو في measurement probe right. سو انت وكانه عندك المالتي ميتر، ديجيتال مالتي ميتر، تمسكيها ويو بروب ات سيرتن بوينت. انت ما بدك الاوتبوت، ما بدي هذا الاوتبوت، انا بدي افحص شو هون السيجنال مثلا. فمثلا باجي بحط هذا اكتيفيتد، باجي هون. فهو طبعا ايش الان في عنده عده خيارات انه بقيس الفولتج، peak to peak voltage, RMS value, VDC, I, and so on and so forth. Let's run the simulation. You see how it changed between 0 and 5 because لأنها طبعا إحنا signal and it's changing with a function of time. this is another advantage. يعني حقيقة لا الطلاب بعرفش طبعا اللي أخذ سيركت 1 وسيركت 2 أما يكون عندنا مختبر ممكن إنكم تسووا المختبر على هذا السوفت وير أوكي، وتتأكدوا تروحوا يعني duplicated في المختبر يعني الموجود عندنا هون. فبيكون عند يعني الأجوبة بتكون قطعا يعني 100%، أو بيكون عندكم فكرة مسبقة شو هي الفاليو اللي انت you should expect it out of your circuit. هذا إحدى الأدفانتج كمان.